Hi Math 111. In this video I'd like to just finish up a tiny little bit of section 1.5 by showing you how to convert between standard form and general form for the equation of a circle. So let's consider an example. I have this equation here for a circle in standard form, and what I'd like to do is write this equation in general form. Okay, remember it's currently in standard form. It's in the x minus h squared plus y minus k squared equals r squared form, and I'd like to write it in general form. Okay, and if you remember from one of our previous videos, that we're able to go back and forth between standard form and general form by using a couple of processes that we've discovered in Math 95 or in your previous algebra courses. Okay. To go from a standard form equation of a circle to a general form equation of a circle, we have to use the process of FOIL, right? We have to FOIL it out. Okay, and then once we have all of those parentheses all FOILed out, we will reorder things and make sure that we have the equation equaling 0. Okay, so let's start out by foiling out these parentheses here. Okay, so remember to interpret those parentheses is that, and that squaring right there, that really means that it says to do x plus 6 times x plus 6. And then there's going to be something else over here, the y minus 5 times y minus 5 equals 9, right? Okay, now let's FOIL that we have, now that we've put all of these, what these squares mean in terms of repeated multiplication here. Okay, so when I perform this first one, I do first, which is x squared. Outside is plus 6x. Inside is plus 6x. And last is plus 36. Okay, and let's do the same thing over here. Plus, that's that plus right there. First is y squared. Outside is minus 5y. Inside is minus 5y, and last is plus 25 because it's minus 5 times minus 5, so plus 25. Ooh, I'm going to run out of paper. And of course that still equals 9. Okay, good. So now let's see if we can clean this up a little bit by combining like terms. So I have x squared in the front. 6x and 6x is 12x plus 36 plus y squared minus 5y and minus 5y is minus 10y plus 25 equals 9. Okay, great. So we're almost there because we've removed the parentheses, but we're not quite there yet because I noticed that there's a certain ordering to the terms and this equation doesn't equal 0 yet. Okay, let's go back one page and look at our general form here. Okay, notice that it's all the squared stuff first, then all the stuff to the first power, right? X to the first and y to the first, right? All that stuff next, and then a constant term, and then it equals 0. So let's get all those x squared and y squared first, then we'll put all the x's and y's, and then we'll see if we can get a constant and make it equal 0. Okay, so if let's see, I just need to rewrite a lot of this, right? So let's see, let's get the x squared and the y squared up here together, right? Remember that addition can be just moved around. You can move terms around as long as you keep the sign in front of it, the correct sign, okay? So next I'm going to put the plus 12x, because that's what it looked like in my general form, plus what came next in that general form. Remember it was x squared and y squared out front. Then it was the x stuff and the y stuff, right? The y stuff came next. So I'm going to put that minus 10y here. And then remember from our general form, the next term was a constant, right? So let's see, are there any constants on this left side? There's a 36 and a 25. Well, 36 and 25 combine to be a 61, and that equals 9. Okay, so all I've done to write this left side is reorder the things that were already there, right? X squared, y squared, 12x minus 10y, and 36 and 25 is 61. Okay, it's still not done yet because remember the general equation has it equaling 0, so let's move this 9 over. So we've got x squared plus y squared minus 12x minus 10y. Let's see, what happens if I want to move that 9 over? I would have to do 61 minus 9, which is 52. Yes? Great. Now we are in the general form, right? If we go back one page. Let's see all the squared stuff, x stuff, y stuff constant equals 0. Okay, now let's see if we've got it right. Let's just make sure. X squared y stuff, y stuff constant equals 0. Good, we are done. So let's go ahead and box that answer just for fun because we can and because we know it's special. Okay, so this is the general form of the equation of the circle, right? These two equations say the same thing. The standard form and the general form say the same thing. They describe the same circle, but they're just different ways of saying the same thing. Okay. Most people usually like the standard form better for good reasons. You can directly see what the center and the radius are. Okay. But some people like this one because there's no parentheses. Personal preference, I guess. Again, remember that these numbers that are here, this -12, -10, and 52, those don't have any direct relationship to the center and the radius, right? Notice I can't say anything about what the center and the radius are just from knowing those three numbers right there. Okay, notice they're totally different than what we know actually is the center and the radius. The center of the circle is -6, 5, and 3, okay, for the radius. And those are not numbers that appear here. So just be really cautious about not interpreting these coefficients here as the center and the radius. Okay, well let's try to go the other way. Let's start out with an equation in general form and try to work it backwards to put it in standard form. So let's take something like this. Let's write the following equation, x squared plus y squared minus 6x plus 2y plus 9 equals 0. This thing is currently in general form. Let's write it in standard form. Okay, well if you remember from our last video, I told you that you're able to go back and forth between standard and general form, and if you start out with general form, you can get back to standard form by doing what's called completing the square, right, which is a fancy process of factoring. Okay, so if you don't remember completing the square, it might be good to look in your appendix of your textbook, look up in the index, look up completing the square, and there will be a review section on it in the appendix. I will walk you through this example, okay, but if you require more reviewing than what I'm going to do here, make sure you find it in your appendix of your textbook. Okay, so what we need to do to rewrite this equation is to get all the x's together and get all the y's together, because notice in standard form all the x stuff is together and all the y stuff is together. So let's first rewrite it by getting all the x terms together. So x squared minus 6x. And I'm going to leave a space here for a second for reasons that you'll discover in a few minutes. I'm going to put a little underline there for a space. I'm leaving a space. Okay. So x squared minus 6x space plus y squared plus 2y. And I'm going to put another space. Again, you'll see why in just a few seconds. Plus 9 equals 0. Okay, so the process of completing the square means that you take two terms like this right here, and you figure out what a term right here needs to be, what a number needs to be to go right here, so that these first three terms here will turn into a binomial squared when you factor them. Okay, and then we'll do the same thing here. We want to put a special number here so that y squared plus 2y plus a number is a really nice factorable trinomial. Okay, so we could factor it really nice and it'll turn into something that looks like this, right? Okay, so let's see. The process of completing the square says to figure out what this number is, right here, to go in that blue line. Okay, you take the number in front of, in this case, x right here. You take that number in front of x, which is -6, you divide it in 2, and then you square it, and that's the number you put here. Okay, so that number that we're going to write there, I'll write it in blue for you. That number that we put right there is actually going to be the number -6 divided by 2 squared. Okay, and let me write that. -6, and then I divide that by 2, and then I square that number. Okay, and that's the number I put here, right? You take this number, which is usually called the b or whatever, -6 divided by 2, and then you square that number. So -6 over 2 is -3, and you square that number and you get 9. So I'm going to write a plus 9 here. Okay, I'm going to do the same thing over here, but instead of taking the -6 from over here, of course I'm going to work with the number in front of the y over here. Okay, so the same thing works here. I'm going to take the number that's in front of the y, which is 2, I'm going to divide it by 2 and then square that number. Okay, so again, you take the number in front of the y, which is positive 2, you divide that number by 2, and you square it. Okay, so that's going to end up being what? 1. So I put a 1 right here. Good? Okay. So again, if you need review on that process of completing the square, see your appendix. Look it up in the index first, and then find the respective appendix pages to review that topic. But now what I see is that when I look at these first 3 terms here, that's a really nice factorable form, okay? If I look at this and I factor these first 3 terms right here, this first 3 terms here, right? This factors into, let's see, x squared would be an x and an x. 9 would be 3 and 3, or 9 and 1, but I know looking at that middle number of 6 that I need it to be 3 and 3. This plus here tells me that they were the same sign, and this one says they are negative. Okay, good. And then the same thing, something similar can happen over here with these next 3 terms. Okay, if I'm going to factor these things, I know y squared, I need a y and a y. And to get a 1, I only have one choice, right? It's 1 and 1. Okay, and to get a positive 1 and a positive 2, I have to have a plus here and a plus here. Okay, all right, so that's these first 3 terms factored, plus, let's put a big plus there, that's this big plus here, plus the factorization of these 3 terms gives me this, plus 9 equals 0. Okay, well, what's great about this is notice that this gives us almost the general, the standard form, right? Okay, I can write this as x minus 3 squared plus y plus 1 squared, and then to make it truly in terms of standard form here, I have to do something here. I have to get this not equal to 0. I have to move a number over, right? I have to move this over. I have to move that 9 over. Wait a minute. Something looks a little fishy here. Why should that concern us? Why should this concern us? Well, isn't that supposed to be r squared? That is supposed to be r squared. That's not good. It can't be a negative number. You can't have r squared be a negative number because that means that r, how would you square a number and have it be negative 9? That's troublesome. That's not good. Perhaps we should consider what we did up here. Yeah. Notice that when we were completing the square up here, what we did is we added 9 over here and we added a 1 right here. Well, we only did that on one side of this long equation, right? We just added numbers on this left side of this equation and all this yuck over here. Did we add anything to the other side? No, we didn't. And remember, one of our algebra rules is what you add to one side of an equation, you must add to the other side, right? So when we were doing this process up here and we added a 9 and a 1 on the left side, we should have done the same thing to the right side of the equation, right? So up here we should have actually added a 9 to the right side and added a 1 to the right side. Right? So when I get down here to this 0, that's not actually a 0 down here, right? That's not a 0. There's actually a 10 living over on this right side. Yeah? That's actually a 10 because there's a 9 and a 1 over there. So that means that this is not a negative 9 living down here, right? That's not a negative 9. When I move that 9 over, I'm actually just left with what? 10 minus 9 is 1. Okay? So that means that our correct equation would be the, let's write this in a nice bright color here. Our correct equation then will be x minus 3 squared plus y plus 1 squared equals 1, right? Good. And that makes much more sense, a positive number right there. Okay. And if you're interested, the center of this circle is what? 3, negative 1, and the radius is 1. Okay, not because there's a 1 there, but because 1 squared is 1, right? Good. Okay, so just be really aware when you're doing this process here of completing the square that you do what you do to one side of the equation. If you add numbers to one side, you have to add them to the other side as well. Okay, great. And again, the center here is 3, negative 1, because that's plus, and the radius is 1.